Hey everyone, this is Arun and welcome to my YouTube channel. I hope you all are doing very well. So today in this video, I'm discussing about the question number 10 from chapter number 2. In this question, we have a retail store in Des Moines, Iowa, receives shipments of a particular product from Kansas City and Minneapolis. So here we have two variables, x equals to number of units for the product received from Kansas City and y equals to the number of units of the products received from Minneapolis. So now, so this question is divided into 5 parts, and each part has its own question. So I solved it out all the 5 parts. Let me go back to the solution. So for part A, which is write an expression for the total number of units of the products received by the retail store in Des Moines. So here I've solved it out. So here we have the variables x, which is defined in the question itself, which is x equals to number of units shipped from Kansas City and y equals to the number of units shipped from Minneapolis. Then for part A, which is write an expression for the total number of units of the product received by retail stores in Des Moines. So which is the total number of units is x plus y. Then part B of this question states that develop an objective function representing the total cost shipments to the Des Moines. So here, since the goal is to determine the cost based on the specific rates provided, which is $0.20 for the Kansas City and $0.25 for Minneapolis. So total cost is 0.20x plus 0.25y, which is having the minimization of the objective. Now part C is to develop a constraint that requires 5,000 units to be shipped to the Des Moines. So here we have x plus 5 equals to 5,000 because we have 5,000 units to be shipped. Then this is for part D, develop constraints to the model of the shipping limits. So here constraint for Kansas City is no more than 4,000, which is x is less than or equals to 4,000. Then constraint for Minneapolis no more than 3,000, which is y is less than or equals to 3,000. So then this is for part E. State a mathematical model for satisfying the demand at the Des Moines, a retail store at the minimum cost. So this is the objective, and we have to minimize the cost. So here we have taken z variable, which is 0.20x plus 25y, sorry, 0.25y, and these all are subjects constraints, which is x plus y equals to 5,000, which is demand. Then x is less than 4,000, which is Kansas City limit. Then this one is y is less than or equals to 3,000, which is Minneapolis limit. And xy is greater than or equals to 0, which is non-negativity. So this is the part E solution. So I hope you like this video of explaining the constraints and the minimizations, how we develop the variables for this question. And we have provided the all parts for this question. So to get this Excel file and to get this solution, you can just reach me out over my WhatsApp channel and my email address, which I will be sharing you in the description part of this video. So if you have any more questions to solve through me, or if you have any issues or you stuck in any questions and you need my help, then I am there to help you. You can request me for that as well. So I hope you like this video, and thank you for watching this video. Have a great day. Take care and bye. We'll talk soon. Bye. Thank you.